In the previous unit, we talked a bit about finding derivatives and using the limit process to find derivatives. And fortunately for us, there were a couple of rules that we learned to make our lives a bit easier when it came to finding derivatives. And we're going to continue that process today. We're going to start out Unit 2 by discussing some rules that we have for differentiation. The ones I want to start off with are the product rules and the quotient rules. So let's break each one down. First off, what does the product rule say? Well, I know this looks like a lot, but all this is saying is when we're finding the derivative of the product of two functions, so let's say f of x, I'm going to just highlight in red here, and I'm going to highlight g of x here. So when we're finding the derivative of the product of two functions, it's effectively the derivative of the first function, so the derivative of the first function times the second function, g of x, plus the derivative of, well, I'll just keep here, the derivative of the second function times the first function. So what this rule is effectively saying is when we're finding the derivative of f times g, we can write this simply as f prime times g plus g prime times f. So the derivative of the first times the second plus the derivative of the second times the first function. So that's effectively it. So let's take a look at an example here. So this first problem, let's just zoom in on this one here, number 1. So we're going to treat this one as if it's our f, and this one here as our g. What we call it doesn't really matter as long as we recognize one function from the other. So we are going to say, and very importantly, we're going to note that we are finding the derivative of f. So the derivative of f would be, the derivative of this function, I should say, is the derivative of the first. So if we differentiate 3x squared minus 2, we would say that this is simply equal to 6x. And we multiply that now by the second function, which is 2x plus 3. Okay, so we just did, right here we did f prime times g. So now let's go ahead and let's add that to, f prime times g. Now let's add that to g prime times f. So the derivative of g in this case is going to be 2. And then f is going to just, we're leaving that as it is, 3x squared minus 2. So we have the derivative of f times g plus the derivative of g times f. And you can simplify this, but I'm fine with you leaving this as it is. But we should probably note that we are going to start working with higher order derivatives in a bit. So if we were to try to differentiate this again, you can see that it might make our life a little bit easier to actually simplify this. For example, this function, or this derivative, I should say, can actually simplify out to f prime of x is equal to 18x squared plus 18x minus 4. You can see that this would probably be a little bit easier for us to differentiate rather than trying to differentiate this here as it's currently in in that form. Okay. The second rule that I want to discuss is the quotient rule. So let me just make some space here. Let's talk about the quotient rule now. Well, what is the quotient rule saying? The quotient rule effectively says when we're finding the derivative of the quotient of two functions, initially it's going to work out pretty similar. We're going to say it's the derivative of f prime of x, or the derivative of f of x, the numerator, so that's what we have here, times g of x, the denominator function. And then we are going to, and I'm going to do this in a different color here, I'm going to highlight that we are subtracting, and that's very important because that means that this is not going to work, we can't use the commutative property here. So we're then going to say the derivative of g, so let me highlight that, actually highlight that, times the numerator. Again, I'm keep on switching over to my pen. And that's all of this going to be over g squared. So let me rewrite this because now we're just seeing a bunch of colors. The derivative of f over g, so where f and g are each functions, we can be written simply as f prime times g minus g prime times f, all of this over g squared. Okay? So let's go ahead and try that in a problem here. So let's go ahead and try, let's say number 3. I think number 3 might be a good one to start with, okay? So actually, let me zoom out a little bit so we can still keep that rule there. So we're going to find the derivative. So we're going to say f prime of x can be written as such. Now, I'm going to go ahead and just move this. I'm going to take this negative and just treat this, put it here in the numerator, just to make our life easier so we know we don't accidentally get mixed up and sign a negative twice. So the derivative of our numerator first, f prime, the derivative of our numerator. Well, now think about this for a second. Our numerator is a constant. So the derivative of our numerator is just going to be 0. And if you wanted to, you could write 2x cubed here. But we already know that all of this entire product is going to be 0. So I can just move on and just write 0. But we're now going to subtract from this the derivative of our denominator. So the derivative of g, our denominator, is 6x squared. All of that times the numerator as it is, which was negative 17. And all of this is over our entire denominator, being very careful with our parentheses, that entire denominator squared. Well, I know we can leave it as it is, but if I wanted to clean this up just a little bit, I can rewrite my let me clean up my numerator. I know it's going to be 17 times 6x squared. We're just going to keep it all positive. And our denominator here, if we write this as 4x to the 6th, I see here that we can do a little bit of dividing. This x squared can go x to the 6th, and we're still left with this is a 4. This 2 goes into that twice, and 3. And if I wanted to clean it up, again, for the intent of what we mentioned earlier, this could be written as 51 over 2x to the 4th. Okay? Let me try another one here before we finish. Let's try something like number 4. This is often a type of problem that you would see in College Board question, as a College Board or AP exam question. So let's try something like this. If we're asked to find g of x, or excuse me, the derivative of g of x. Let's find the derivative of g of x. Now, we're told that g of x is x squared times f of x. So let's set that up first. So if we apply the product rule here, we're going to say 2x times f of x plus the derivative of our second function, f prime of x, times x squared. All right, so there's our derivative right now. Now let's actually find, and I don't know if you can see it here, I probably should note that. Now let's actually find g prime of 2. So let me actually write that underneath. G prime of 2, what is that? Well, that's just this derivative evaluated at 2, which is 2 times 2. Now f of 2, and I'll just write that in, I'll do that final substitution in a bit, plus f prime of 2 times 2 squared. And just to finish this up, 2 times 2 is 4. F of 2 we're told is 3, so 4 times 3. F prime of 2, it's given to us that that's equal to negative 1 times 4, and all of this just comes out to 8. All right, so that is our introduction to product and quotient rules, and we'll see this a lot more as we continue on in the course. Let's switch gears a little bit, and let's look at some trigonometric rules. So let's look at some trigonometric rules for differentiating. There are many great resources out there that will break down the derivations, and I can link some below in the description. But for now, I'm just going to provide them to you. Just know that the derivative of sine is cosine x. Derivative of cosine x is negative sine x. The derivative of tangent is secant squared x, or secant x, all that function squared. And we have negative that's a terrible S, negative cosecant squared x. This would be the derivative of secant x is secant x times tangent x, and the derivative of cosecant x is negative cosecant x, cotangent x. And there are a lot of different tips and tricks that you can use to help memorize these, and the bottom line is you're just going to need to commit these to memory. One little helpful hint, for example, is that all the derivatives of all the co-functions are always going to be negative, for example. We can also see that tangent and secant are always related to each other, whereas cosecant and cotangent are related to one another. So those are some different tricks, and as you go along, I'm sure you'll use some other tips and tricks to help memorize these, but they're not too bad. So if we wanted to differentiate a couple of these functions now using these trigonometric rules, let's do that. Let's try something like, start with number 5 here. Start with something basic. Okay, so f prime of x. Well, finding the derivative here. Well, keep in mind, at first glance, we might think we're applying the product rule, but remember that 3 is just a constant. Now, technically, we are applying the product rule, but we don't really need to write all that out or the two sums because the derivative of any constant is always just 0. So we can just treat this like it's just a scalar or a constant there and just write this as 3 times sine x. This next part here, I'll just do this in green. The derivative of x is just 1. And we know that the derivative of negative 2, a constant, again, is just 0. Let's try another one. Let's try number 6. The derivative of this function here. Now we are going to apply the product rule. So we can say the derivative of x is 1 times the derivative of tangent x, which we said above is secant squared x, plus, now we're still not done with this yet. We're applying the product rule. So we then have to write x times, excuse me, the derivative, or no, I was right the first time, x times the derivative of, oh, I apologize. I completely botched this. Let's start from scratch. I started differentiating both. I apologize. Okay, so again, we're starting here. The derivative of x is 1. And then we're just going to write tangent x. We don't need to differentiate that. So the derivative of x is 1 times just the second function as it is, plus, let me write that, plus, now we're going to leave x as it is, times the derivative of tangent x, which is secant squared x. Now, to finish this off, let's write the derivative of x squared, which we can say is just 2x. All right, so despite a bumpy start or a rocky start, we got that figured out. So that should be that. And let me try one more. Let's try number 7. Let's find the derivative of this. This was one that involves the quotient rule. So we're going to say the derivative of the numerator, which is 1, times the denominator, so that's just sine x, minus the numerator times the derivative of the denominator, which is cosine x. And all of this is over sine squared x. So I'm going to allow you to try some of these other practice problems on your own, but one problem that I do want to jump to is number 9. Let me do that problem before I finish up the video lesson. So number 9 here, we're going to find the equation of a tangent line to the graph given this function here. And we're told that we want to find the equation of the tangent line when theta is equal to pi. So first things first, we know by now when we're finding the equation of a tangent line, we need to first find the derivative. So y prime here is going to be, using now our trigonometric rules and our quotient rules, we could say the derivative of the numerator, cosine theta, times the denominator. So that's just going to say, we're going to say this times theta, minus the derivative of, the function, the numerator as it is, so sine theta, times the derivative of the denominator, which is just 1. And all of this is over theta squared. Let's clean this up because we're going to actually need to use this. So actually, we can just jump to it as it is. Let's evaluate this derivative now at pi, because we need to know the specific slope at pi using this derivative. So cosine of pi times pi minus the sine of pi times 1. All of this over pi squared. Well, if we evaluate each of these trig functions, the cosine of pi is just negative 1 times pi is negative pi. Sine of pi is 0, so we don't really have to write anything else after that, and all of that is over pi squared. So this is just negative 1 over pi. So what we've just found is the slope of our tangent line at theta is equal to pi. Now the last thing we need is the point or the coordinate itself. So what is y of pi? So at that point, pi, what is the coordinate? So sine of pi over pi, which is, again, sine of pi is just 0. So 0 divided by anything is 0. So we can write our equation of our tangent line as y minus our y value, which we just said was 0, is equal to our slope, 1 over pi, negative 1 over pi, times x minus pi. Or actually, it's a function in terms of, we can use this. And there is the equation of our tangent line.